Okay, so this is the last new item before the common assessment in the fall, and this is all we're doing. So sometimes it is very time consuming. It is very time consuming to carry out an entire binomial probability. If I said, what is the probability that you get more than 10 questions right on a 100-question exam, it will take a long time to figure that out. Some trials can also be very expensive. If I wanted to find out how many cereal boxes do I need to buy so that I get all the Tiger Woods and Serena Williams and Lance Armstrong cards, I might end up having to buy a lot of cereals before I can actually get my answer. Because of this potential difficulty, both in terms of cost and time, resources, etc., statisticians have come up with an ability to carry out what are called simulations to model real life without actually having to go through and necessarily punch everything into the calculator or actually go out and buy like a bunch of cereal boxes or whatever it might be. So what do we mean by a simulation? We mean the following. There are two types of simulations. They're closed and open, as you can see here on the board, on your sheet. And let me get my notes out so I can better convey this.
Did you get that?
I do. This one does. So let's take a look at the first problem. So we have here a student has to take a 10-question multiple. Yeah, two. A student has to take a 10-question multiple choice test. Each question has 4 possible answers. Use the 5-step method, I'll explain what that is, to estimate the expected number of correct answers that the student will answer correctly, given that they guess, conduct 5 trials. So, first kind of simulation is a closed simulation. And a closed simulation is the following. If we have a fixed number of outcomes, I think a better way of saying this is a closed simulation is very similar to a binomial probability, wherein we have kind of a fixed number of, instead of using the words trials, I'll use maybe options, instances, occurrences, so 10, a fixed number of occurrences, and we are calculating the number of successes. So, and the way we carry this out is in the following way. And I'll carry it out and model these steps. So, if we know that there are 4 possible right answers, and I'm just guessing, the probability I get the question right is how much? More than 3 people should know this. If there are 4 4 answer choices, what is the probability I get the question right? Okay, let's try it again. Every single person in this class knows the answer to this question. If there are 4 answer choices, and I'm completely guessing, what is the probability I get the answer right? 1.25. So probability of success is 0.25. So, ideally, right, we could do this on a calculator, but the way to carry out a simulation is the following. Let's say, well, we have some random numbers here. And I'm going to write the following statement. We have 10 random numbers. Right, we have 10 random numbers. We have every number from 0 to 9. We have every number from 0 to 9. And if the probability of success is 0.25, I could say the following. I could say, well, if, hold on one second. If I get a 0 or a 1, I succeed. And if I get a 2, 3, 4, 5, 6, 7, 8, or 9, if I get a 2 through 9, I fail. 0, 1, 0, 1, 1, 2, 3, 2, 3, 4, 5, 6, 7.
You
2
heard
through
me?
7.
You heard me?
I'll explain how you do this. 2 through 7. So how did I do this? I said, well, the probability of, just give me 2 minutes. Let me walk through the explanation. So the probability of success is 0.25. So I said, well, if I take the numbers from 0 through 7, 0, 1, 2, 3, 4, 5, 6, 7, there are 8 numbers, which means 2 of them should be a success and 6 should be a failure. 2 out of 8 is 0.25. Does that logic work? That's the first place to start. So we say, well, and then I'm going to say just skip numbers 8 and 9. So I said, well, I've got 10 numbers, 0 through 9. In an ideal world, I could use all 10, but the problem is there's no exact value for 25% of 10. So I'm going to say, let me only focus on 8 numbers. And I'm going to say, if I get a 0 or a 1, I succeed, which means I guess right. And if I get a 2 or a 7, I fail. So let me model what happens here. So the first question, I got a 4. So I did not get that right. Second question, I got a 0. Got that right. Third question was a 3. That's a failure, so I didn't get that right. 3, didn't get that right. 6, didn't get that right. 5, didn't get that right. 0, got that right. 6, didn't get it right. So how many questions have I gone? 1, 2, 3, 4, 5, 6, 7, 8. A 5, I didn't get that right. I'm going to skip the 8 because the 8 is not included. And the 3, I did not get it right. So here are my 10 questions on the test. On the questions where the answer was a 0 or a 1, I got those right. Every other number was wrong. And I skipped 8 and 9 because if I had included it, the math would not have worked out. So what this is saying is, in one trial, here's a trial. In trial number 1, I got 2 questions right. 2, so maybe we should make a little chart here. Trial 1, 2, 3, 4, and 5. This is called a trial. I got 2, and this is questions right. Okay, let me stop here after the first trial and take questions. Eddie Ball.
So every group of 10 is one test?
Well, not every group of 10, because remember, the 8 and the 9 don't count. Because the 8 and the 9 are not involved in this. Because if we were to include the 8 or 9, then the probability of success would not be 0.25. So I've excluded 8 through 9. I'm only looking at 0 through 7, which is 8 numbers. 2 of the numbers are correct. 6 of the numbers are me getting it wrong. Tomorrow. We'll come next. Tomorrow.
So you have 10 questions, right?
10 questions on the test. Yep.
And then you select 4.
There are 4 answer choices. Right there. So it's like A, B, C, D.
Okay. So each of those, each have a 0.25 or altogether?
No. So on question 1, right, the probability of me getting it right is a 25%.
Okay.
And on question 2, it's also 25%. And question 3. So what I said is, well, let's just, instead of having like A, B, C, D in question 1, and then E, F, G, H, let's assume this is numbers, well, 0, right? Because could imagine like 0 and 1 are the good answers. These are the correct answers. 2, 3, 4 are wrong. 5, 6, 7 are wrong. So only if I get A or E am I right. Only if I get 0 or 1 am I right. The other ones don't count. And then the 8 and the 9, well, they're just going to be excluded because they don't fit nicely into the pattern of 4. You go ahead.
So how would the probability, say if you got them all right, what would the probability be?
The probability of me getting every question right would be 0.25 times 0.25 times 0.25, like 10 times.
Okay.
Right? But what this said in our first trial was when we just kind of like looked at this random chart of numbers, right? I only got 2 of the questions right. The other 8 I didn't get. And now I'm going to do the trial again and again and again, doing it about 5 times. Eddie.
You said you were skipping 8 and 9. Why did you only take out one of them?
Because I scratched out this 8 because I did not get to the 9 yet because that was I only did 1 trial. I only focused on these numbers from here to here. I then have to go do these and then I'll keep going. So I only took out this 1 8 because that was the only 8 that came up. No 9 even appeared. No 9 even appeared. No. Number 8 and digit 8 and digit 9. Dex.
Do you count 0 as a number?
Yeah, we are.
But it has no numeric value. It's void.
Oh, this is like very philosophical. I don't necessarily have an answer to this.
I'm just saying, it's kind of like...
Keep it going.